In this video, I'm going to show you guys how to name aldehyde and ketone. But before I actually venture into that, I want you guys to understand that aldehyde and ketone, they are carbonyl compound, right? And the only difference is just that we are having a carbonyl group connected to hydrogen. This is the case of aldehyde. And one thing about aldehyde is that it will always be on carbon number 1. While ketone is a carbonyl compound that is connected to an alkyl group. Both are alkyl group. We are going to have alkyl group. That shows that the carbonyl compound is directly connected to a carbon, two other carbons, right? So this is basically ketone. Why this is aldehyde? So this video is going to be on the nomenclature of aldehyde and ketone, and both the structural and the skeletal formula. That's actually what I'm going to be writing out. Now let's say we have the first one here, right? Let's say we have this case, and here we are having double bond O, right? So what's going to be the name of this compound? If you look at this very well, we're having carbon 1 here, carbon 2 here, carbon 3 here, and carbon 4. So in that case, since we're having 4 carbon atom, that basically means we are going to have boot here, right? 4 carbon atom simply means boot, right? Now the thing is now that, are we going to, let me say, are we going to just call just the name, like just write it out like that, or we still have to check the bond? Yes, you have to check the position of bond, because you have to check the nature of the bond, because if you look at this, it's a single bond all through. So this is basically butane, right? Butane, since it is on position number 2, the compound is on position number 2, that's going to be butane 2-one, right? Butane 2-one. That's basically the name of this compound. Now let's say we have another one here, right? And in this case, we are having CH3, right? We are having C double bond O, right? And here is actually CH3. So in this case, what's going to be the name? This is carbon 1, carbon 2, and carbon 3. 3 carbon atom is basically what? Prop, right? Then prop. Since we are having single bond here, it's going to be propan. Then you're going to have carbonyl compound, which is actually ketone. This is ketone, and it's going to end with what? With ONE. Since it is ketone, and the carbon is in between what? Two other alkyl groups. So we are going to end it with ONE. But if it is just carbonyl compound directly connected to hydrogen and a carbon here, this aldehyde, so it will always be on what? On position 1, and you're going to end it with Al, right? So this Al, which end that of aldehyde, and this ONE, which end that of what? Of ketone. So since this is on carbon number 2, we are going to have propan 2-one. That's what we're going to have. Now let's see another compound that we have. Let's say we have this CH3, C double bond O, right? We are going to have H is here, right? So let's go ahead and name this one. It's very, very simple. We are having 2 carbon atom here, 1, 2. 1 here, the carbonyl compound here is at position 1, and we're having this guy here on carbon number 2, right? So in that case, this is basically ethanol, right? Ethanol, or you simply say ethanol, but it's still the same as what? Ethanol, right? So one thing I want you guys to understand is that aldehyde will always be on carbon number 1, while on any other position, ketone can actually be found on any other position. Now let's go ahead and write some other compound out. Now let's take a look at this compound here, right? The first one that you are seeing here, we are having everything that you are seeing here is actually what? Aldehyde functional group, and then we're having a double bond at this point. So in that case, what it means is that I'm going to start my numbering from this side. I'm going to have carbon 1, carbon 2, and carbon 3. So I'm having a double bond in between carbon 2 and carbon 3. So since we are having 3 carbon atom here, that basically means this is going to be prop, right? It's going to be prop. And in that case, I'm not having any attachment. I'm not having any attachment, right? So that basically means I'm having double bond instead at this point at position number 3, right? So in that case, I'm going to have propene, right? Propene. And the reason why we are using propene is because we are having just a single double bond here, right? We're having a single double bond here, right? So in that case, we're going to have propene. Then the E that's supposed to last here, we're going to change it because we are having an aldehyde functional group here. So this is going to be propene 1-ha, right? And at the same time, what's the position of this propene, right? What's the position? The position is actually what's on carbon number 2. So we're going to have 2 propena, or you simply say propene prop 2 in 1R. Whichever way you name it, you are actually right. Prop 2 in 1R. Right? So that's basically how to name this guy. Now let's go ahead and name this one as well. This is carbon number 1, this is carbon number 2, carbon number 3, and carbon number 4. 4 carbon atom is basically what? That's boot. Right? You check if there's what? Double bond. Yes, there's double bond here, right? And at position number what? 2. So we're going to have boot 2 in, right? Then still we are having carbonyl compound here, which is what? 1R. Boot 2 in 1R. That's what we are going to have. Now let's take a look at this guy as well, right? Let's take this guy as well. This carbon 1, this carbon 2, this carbon 3, this carbon 4, and this carbon what? 5. So in that case, we are having aldehyde at this position, and this 5 carbon atom. 5 carbon atom is basically what? Is basically pent, right? So since we're having pent here, and on position 4 we're having what? Our double bond here. So this is going to be pent 4 in, right? Then again 1R, or you simply say pent 4 in 1R. Pent 4 in R. The same thing. It's very, very simple. You can just put 1R here, or you simply write it as 4 pentenar. It's still the same thing, right? So that's just it. Now let's go ahead and write another one. So now let's take a look at this question that we have here. So in that case, if you look at this first one, we are having carbon 1 here, carbon 2, 3, and 4. So on carbon 2 and 3, we are having 2 carbonyl compound, which is 2 ketone group, right? So in that case, what do you think we are going to do? Just go ahead and pause this video and make sure you solve it and drop your answer in the comment box below. So in that case, if you look at the bond between all the carbon atom, it is actually single or true. And we are having 4 carbon atom here. So I'll basically call this guy here boots, right? Since it is single bond or true, I'm supposed to have it to be butane, but I'm having a functional group here, so that I'm going to drop this E off. So I'm having butane, which is butan, right? So in that case, on position 2 and position 3, I'm having 2 ketone functional group. So I'm going to have this word to be 2, 3, then we're going to have dione. So this is basically butan 2, 3 dione. Now, if you look at this second case that we have here, we're having carbon 1, carbon 2, carbon 3, carbon 4, right? Carbon 5, carbon 6, and carbon 7, right? Now, how can we go ahead and name this guy here? It's very, very simple. Numbering forward and backward, this is basically what we have. And we are having our ketone functional group on carbon 2 and carbon 6. If you go ahead and number back, like in the backward direction, we are still going to have 1, 2, 3, 4, 5, 6. So it is still the same thing, regardless of the way that we actually choose to number it. So in that case, since it is 7 carbon atom, I'm going to have it to be ept, right? This is going to be ept, right? Ept. And I'm writing ept because I notice that there is double bond at position 4 and 5. So since there is double bond at position 4 and 5, at position 3 and 4, rather, if I consider numbering like this is 1, 2, 3. If I consider numbering backward, it is between 3 and 4. Right? If I'm numbering forward, it is between 4 and 5. So let's just follow this side. So we are having ept, then here is going to be ept 3 in, right? Then I'm having 2, 6 dione. That's what I'm having. It's very, very simple, right? Just take a look at this. Let me just go ahead and re-explain it very well, right? So if you number forward and backward, look at what we are going to have. Look at what we're going to have. We're going to have, look at this. We're having 1, 2, 3, 4, 5, 6, 7, right? So in that case, if you number backward, we're going to have this basically 7. This is going to be 1. We're going to have 2, 3, 4, 5, 6, 7. Now, on position 6, we're having a carbonyl compound. On position 6 as well, on position 2 as well, we're having what carbonyl compound. Right? Regardless of how we try to label it, how we try to, let me say, count it, whether backward or forward. Now, but if you look at this is carbon number 3. The double bond is between what carbon number 3 and 4. So we choose what carbon number 3. Not that we are trying to compare, like, let me say, not that we are trying to consider the alkene as the priority here. No. since we already know that the lowest possible number for our combining compound is actually 2 and 6, so it will make sense if we actually consider the double bond that is in position 3 and 4 rather than 4 and 5. So that's why we have F3 in 2, 6 down. Now let's take a look at this question that we have here. In this case, this actually aldehyde. Then we're going to have number 1, carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. Backward as well, carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. When it comes to aldehyde, we always start counting at carbon number 1. That's just it. So the forward counting is actually the one that is favorable in this case. So since we are having 5 carbon atoms simply indicates that's actually, we are going to have it to be pent, right? And we don't have any double bond, so this is going to be pentana, right? Pentana. But we are having at position 4, we are having let me say an attachment here, as you can see, and this attachment is what is cyclic, right? It's basically something like this. We have carbon here, right? We have carbon here, another carbon here. This guy is double bonded to each other. We are going to have single bonded to each other. So this is basically cyclopropyl, right? But in that case, are we going to call it cyclopropyl? Since we are having a double, we are having just a double bond, like we are having double bond at one position here. Will it still be cyclopropyl? That's exactly what we just need to consider. So the whole name is going to be, since it is attached to carbon number 4, I'm going to have it to be something like this. Let me quickly rub this side up, right? I'm going to have it to be something like this. It's going to be 4. Then you open a big bracket, right? See, this is cyclo, right? This is going to be cyclo 4, cyclo, right? Prop in the sense that it is 3. But if you look at this very well, this is carbon 1, this is carbon 2. On carbon 2, that's actually when we have double bond. So this is going to be cycloprop 2, right? Ene simply means like we are talking about let me say the alkyl group, but it has double bond. Enil, that's what we have. Then you close it. Then the parent name, that's going to be what? Pentana, right? Pentana, or you simply say pentan 1R. That's basically the name. It's very, very simple, right? So now let's go ahead and name this one that we have here, right? So let me just simply cut this out. Now look at this. How are we going to name this guy here? Let's just count everything here. Everything here is actually what? 6, right? And 6 carbon atom simply means what? It is what? Cyclohexane, right? Since the 6 carbon atom and it doesn't have any kind of of double bond or triple bond rather. So this is basically cyclohexane. But let's look at something here. Are we going to start counting from here up to this side, or are we going to make this guy here? Are we going to consider this guy here as a functional group? That's where the question is, right? That's exactly where the question is. That are we going to consider that one as functional group, or we are going to consider the one that we have here, right? Or we are going to consider this alkanal here. What happens is that everything you are seeing here is basically an attachment. You call it an attachment regardless of the number of carbon atom. Although if you look at this, the number of carbon atom in this cyclic form is actually greater than that of this one that you are seeing here. This is basically 2. But that's not it. Regardless of it, but since we are having a carbonyl compound here, this will take up the priority. So you are going to start naming from this guy here instead of of the cyclic structure. So you start counting from here. This is basically 1 and 2, right? So in that case, this is basically cyclo, right? Or you simply say 2 cyclo, right? Hexane, right? 2 cyclohexyl, right? 2 cyclohexyl. Then in that case, you are having what? Ethane 1Ha. 2 cyclohexyl, ethane 1Ha. That's basically what we are going to have. Now let's take a look at this question that we have. This is the last structure I'm going to name in this video. So you can as well go ahead and pause this video and try to name them. Now look at this. The first one that we have here, we are having a cyclic structure, and this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. It is actually 5 carbon cyclic structure, right? So, and in that case, we are having keto group at this point, right? We are having keto group at this point, and at the same time, we are having 2 other alkene at this point, at this edge. These are kin and these are kin. So if I start to name from this side, this is going to be 1, 2, 3, 4, and 5. So my double bond is on position 2 and position 4. So if I also start to name from this side, this is going to be 1, 2, 3, 4, and 5. So whichever way I actually count, or whichever way I actually start naming this compound, the double bond is actually on position 2 and 4. So in that case, I'm going to have this to be cyclo, since it is 5 carbon atom, cyclo pent 2, 4, right? Diene. That's what I'm going to have. Then 1. Now the question is now that, is it going to be 1R or 1 own? That's the question, right? That is it going to be 1R or 1 own? No, I said something earlier at the beginning of this video. I said aldehyde, they are directly connected to hydrogen, right? While ketone is connected to two let me say a key group, right? That's basically what we said at the beginning of this video. But if you look at this case now, when we start counting, we have this carbonyl compound to be on carbon number 1. Now the question is that are we going to take it to be ketone or aldehyde? That's what the question is. Now in that case, it is going to be ketone. And the reason why it's going to be ketone is that this is a carbon here and this is a carbon here. Then what is the general formula, or let's say the functional the structural formula of ketone? It is basically carbonyl compound connected to carbon and towards a carbon. That's basically ketone. So this is a carbon here, this is a carbon here. So this is basically ketone. So we're going to have cyclopent 2, 4, diene 1 own. You can only see that when it comes to cyclic hydrocarbon. But when it comes to straight chain, ketone, they are always found within carbon 2. Right? Carbon 2 upward. They can never be on position 1. Whenever you see carbonyl compound on position 1, it is basically aldehyde. But in the case of cyclic hydrocarbon or cyclic compound, it is different. Now, let's go ahead and check the second case that we have here. Now, if you look at this very well, we are having carbon 1 here. This is carbon 2, 3, 4, and 5. Now, on position 2, we are having chlorine. On position 3, we are having our ketone. On position 4, we are having what? Bromine. Now, if you consider alphabetically, like in alphabetical order, bromine comes before chlorine, right? You know, whichever way we start to count here, you know, we are going to have 1, 2, we are going to have this 3, 4, and 5. Chlorine is on position 2 and 4. Bromine is on position 2 and 4. So the one that we are going to give the priority to is one that will first come that lead alphabetically. So B comes before C. So I'm going to follow this order to name. That's what I'm going to follow. I already know my ketone is on carbon number 3. So this name is going to be, we're going to have 2 bromo, right? 2 bromo, then followed by what? 4 chloro. Since it's 5 carbon atom, 5 is actually what? That's pentan. Pentan in the sense that there is no double bond. Pentan. Then we're going to have 3 own. That's what we're going to have. 2 bromo, 4 chloro, pentan, 3 own. That's going to be the name. Now let's take a look at this one that we have here. You can go ahead and try this at the same time. So make sure you drop your answer in the comment box below. So let's go ahead and try this. This is basically carbon 1, this carbon 2, this carbon 3. Now we are having 2 carbonyl compound on position 1 and 3, right? And in this case, on position 1, the carbonyl compound is connected to hydrogen. Then yes, of course, this is aldehyde. And the reason why it's aldehyde is because aldehyde, in the aldehyde structure, carbonyl compound is connected to hydrogen and just a single carbon, unlike ketone, which is connected to 2 other carbon. Now in this case, we are having the carbonyl compound connected to hydrogen and just a single carbon. And at the same time, this guy as well is connected to a hydrogen and just a single carbon. So what am I going to call this guy? I'm going to call it, since it is 3 carbon atom, this is going to be prop, right? Then propan, because I'm having single bond all through. Propan. Then you come back here, we are having on position 1, we are having 1, 3, right? Then this is going to be diher. 1, 3 diher. And the reason it is diher is because we are having 2 carbonyl compound, like two carbonyl compound, one on position 1 and the other on what? On position 3. So the answer is, the name is going to be propan 1, 3 diher. So that's just the end of this nomenclature of functional group, aldehyde and ketone. In my next video, I'm going to be releasing that of alcohol and amide, right? So if you enjoyed this video, don't forget to like, share and subscribe. It's very, very important. Subscription is very, very important and it is totally free. Just click on the red button below, on the or white button, just click on it. Then that's all. Thanks for watching.